All right, welcome everybody to just a general office hours session. Let me know in Discord if you have any questions. Otherwise, I will just continue through our elementary school math course and do some problems as I feel like it, unless there are any other requests. Let me just check my audio here and everything looks good. I can move this guy. I should remember to move it to the T. Then everything is in place. Good, good. Okay, I'm just gonna start chatting. See what I want to do, unless there are other questions. Feel free to join the Discord server and chat about any of this or any other topic. So I'm just going to start at the beginning, patterns and sequences. Let's go look straight at some problems. Can I zoom this in a touch? Oh, I just want to zoom it in just a little bit. Yes, I need to get just at the T. Then I can click on zoom. There we go. Okay, let me get something to write on. There we go, new page. All right, let's do some math. Okay, I am gonna do maybe problem 1.1 number 2. Problem 1.1 number 2. I have the sequence A, B, B, A, B, B, A, and I want to know what is the 63rd entry. So the pattern here is a sequence of 4 letters that repeat, and I know the next 4 will be the same, A, B, B, A, and so on. So I want to know what is here in position 63. Now they do the A, B, C patterns in grade 1, actually. I've seen it in their workbooks. Now, maybe not asking for the 63rd one, but it's definitely something to be aware of, these kinds of sequences. They spend a lot of time on this, actually. So I know how close to the 63rd position can I get with my 4 letters repeating themselves? Well, I can get to 60 with another 4, and this is going to be the 60th one because 15 times 4 is 16. So I know right up to this at position 60, let me just line them up a little better perhaps. A, B, B, A is going to be at position 60. It's the end of this for loop. So 61 is going to be another A, B, I'll do it like this, 61, 62, and therefore 63 will be a B. So let's say position 63 is a B, and I'm done. But it's much more important to know why it is a B in position 63. Yes. Now, admittedly, the other questions here in problem 1.1 makes a little more sense once we come back and think of them in terms of arithmetic sequences and so on. So I just wanted to do the letter one. Good start. Since there aren't any other questions, I'm just going to ramble on, do my own thing, unless I get interrupted. Problem 1.4. Let's look at some problem 1.4 ones. That is all about using a formula. Using a formula. 1.4, right? So we have a basic formula. An explicit formula is certainly more basic in that I simply plug in the position. Let's do number 3, for example. Number 3. n squared plus, was it 2? It was. So what's the question? I should read the question. Find the first 5 terms in each of the following sequences. 1, 2, 3, 4, 5. And in our course, this was a long time ago, so it might need some refreshing. So I write my positions underneath, like so. So for our level, we're always going to start at position 1. And an explicit formula simply plugs in the position for n and calculates what the term in that position is. So 1 squared plus 2 is a 3. 2 squared is 4, plus 2 is a 6. Then n is 3, so 3 squared is 9, plus 2 is 11. And I keep going like this to get an 18 and a 27, and I am done. But perhaps we need some practice with recursive formulas. So we can do, for example, let's do, it doesn't matter, 5 or 6 doesn't matter to me. Number 5 is fine. There we have a different kind of formula. So let's copy the formula first. I'm given a1 and a2, negative 2 and 5. Yes. Then an is 2 times an minus 1 plus an minus 2. Now this gives me the rule for how to calculate future terms using previous ones. So if I look at my sequence here, 1, 2, 3, 4, 5 positions they want. Position 1, position 2, position 3, 4, and 5. Now I have 2 of them already, so it's a lot of work done for me. It's nice to get to a level where I can interpret what this recursive formula is really asking me to do. It's an instruction for how to get this next position. It says the term in that position is called a 3. To get that, I am going to have to calculate 2 times a 2, which means 2 times the previous term, 5, plus a 1, because n is 3, which means the term 2 steps back from where I am, which is negative 2. I then calculate that, and I get an 8. Now you can always write this down like this, but it's nice to just interpret and say in words what is happening here. This is happening more and more with my kids as well, where I get them to just talk it out. Tell me the story. Which steps are you doing? What are you doing? When? And it makes a huge difference. Being quiet in your head and just doing everything, trying to get to the final answer. No, talk it out. Tell the story of what is happening. So let's do it for the next one. Now n is 4, so I'm done with this one. I'm at 4. So the instructions say take 2 times the previous term and add the one before. So that is 16 plus 5 is 21. And then we move on to the next term, position 5. It doesn't actually matter what the position is because I now understand what the instructions are. It's all relative to my position. N minus 1 means 1 position back. N minus 2 means 2 positions back. So the instructions here are telling me calculate 2 times the term 1 position back and add the term 2 positions back. So 2 times 21 is 42 plus 8 is 50. And I'm done. Let me know if there are any questions on this basic formula use question. I just have to close the door. I'll be right back. All right. Let's see where we're at now. There is a question. Question on 1.1 number 10. 1.1 number 10. Let's go there. 1.1 number 10. Number 10. Yeah, I mean, first of all, we can totally do it. I wouldn't worry about these too much. It's just a mix of basic questions. Some of them make more sense once we look back after having done arithmetic sequences and geometric sequences and so on. Some of them are just for fun, like number 10. So we have number 10 here. Let me zoom in. I lost my zoom. Where is my zoom? There it is. Zoom. For number 10, 142,857, 142,857, 142,857. So I see the pattern. They give me enough digits to see the pattern. Let's just write it down so we have something to talk about. I'm not sure why you said sorry, but I'm sure everything is fine. Problem 1.1, number 10. Which one does it start with? 1. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. 1, 4, and so on. All right. Now the pattern here repeats in this section over here, then again, and so on. So I have a section of 6 numbers, a window, or if you will, every 6 numbers repeat itself. So they want to know where's the 40th entry. So in position 40, what is that number over there? So now with my 6 section repeating, how close can I get? Let me do it over here. I can get to 34, 35, 30, whoopsie. 36 will be a 7 again, because 6 times 6, multiples of 6. So that'll be another end section. So then I just keep going to 37, 38, 39, and 40, because that's a new section here. 1, 4, 2, 8, Oh, that was wobbly. And in position 40 is the number, or the term is 8. But again, it's important to understand why, so that we can teach others and understand and take this, where is it now? This AB concept a little further, but it's exactly the same, really. The same argument, the same concept. Nice. Okay, good. Feel free to interrupt me with any questions you may have. I am just randomly doing stuff so that it's not awkward silence. All right. So we've done a recursive formula. I like to make sure that this is even on the final exam. Where is the final exam questions? It's not here. It's in our course specific chat. Let me just go there and double check. A, B, E. Okay, so yes, for sure. Let me see here. So from this first part, we need to do basic sequences, we need to do arithmetic sequence concepts, and we need to reread that Fibonacci sequence portion. Like always, yeah, okay. ABE, good. So we've done half of it. The second half is on problem, is a problem 1.5 style question, where we have to know our 4 basic sequences, I call them, and adapt them to slightly adjusted versions. Just going to turn your volume down a touch. Okay, so I need to just check my classroom chat if there's any questions. No, okay, good. So let's make a new page here. Again, I'm just randomly doing questions until someone asks something specific. So our basic sequences, let me just get the order here, it's the same. So powers of 2, powers of 3. So AN, powers of 2, powers of 3, not powers of 4, square numbers, and cube numbers. Now I think there was a typo somewhere. Can't remember if it was fixed. Powers of 2, again, we're going to start with position 1 always. So 2, 4, and 8, and so on. 2, 2 squared, 2 cubed, 2 to the power of 4, however many you may want here. Powers of 3, so 3 to the power of 1, 3, oops, that's an ugly 9. 3 to the power of 2, 3 to the power of 3, 81. I think there was one missing. Was it 81 that was missing? No, 81's there. Whoopsie. Can't remember now. And so on. 4 numbers would be fine. 5 may be better, but I think you can get away with 4. Square numbers, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. Cube numbers, 1 cubed, 2 cubed is 8, 3 cubed is 27. They're all in the book here. 4 cubed is 64. 5 cubed is 125, and so on. So these, of course, it's open book, so I can just look them up, right? Previously, I had to know them in some way. So our challenge now in problem, let's go there, 1.5 is to see how the formula is adjusted to get this new sequence. So problem 1.5, number, random number, I don't know, 3. Number 3, let's write down the sequence first. 2, 8, 26, 80. 2, 8, 8, yeah, 26, 80. Okay, so now my first goal is to determine which of the 4 basic sequences is this one coming from. Now, in a way that it's adjusted consistently to give me this resulting sequence. With a little bit of trial and error, it is the second one, the power of 3. So I can write here, underneath it, perhaps, my powers of 3, like so. Powers of 3 is 3, 9, 27, 81, and so on. How is this one adjusted to get to my given sequence? I could say it in words, perhaps, each term minus 1. So that means whatever I get, so this guy has a formula that I'm trying to find. Whatever term I get from 3 to the n, my reference sequence, I need to take that term and subtract 1. Now, of course, I can test this. So it might feel a little bit like guess and check, perhaps. That's okay. I can make some space and say, forget everything. Let me just check if this formula gives me what I'm looking for. So if I'm in position 1, n is 1, I calculate 3 to the power of 1 minus 1, 2. Okay, good so far, but I need to get the whole sequence. Now position is 2, so n is 2. 3 squared is 9, minus 1 is 8. Now position 3. 3 to the power of 3 is 27, minus 1 is 26. Now position 4. Plug in a 4 for n. See what I get. I get 80. So yes, it is giving me back my original sequence. So therefore, that is the correct formula. Simple as that. Well, it's not as simple as the previous question, but if I just follow the systematic approach, then there's nothing that is overly complicated. Find which one can this come from, then figure out how, adjust the base formula accordingly, and test. Does it give me back my my given sequence? If it does, then it's right. Simple as that. Any questions on this, which I think overall, for this part at least, is the hardest question. Little question there. I was just wondering if there's an outline for the Math 108 final. There isn't one yet. I will put one up later today. But it's pretty much going to be the quiz questions are the representative questions from all 4 quizzes. But I will put up a list to just verify that later today in our course chat. right, someone's typing. Let's see what question they may have. Oh, I turned down her volume. It's not a lot of background noise on my end, but yes, as a general rule, if you can either use push to talk, which is what I'm doing. If you're not on a phone, I highly recommend push to talk. And you don't have to leave. Now she's gone. Oh, we scared her off. Oh, there she's back. Okay. I thought you scared her away. Um, Push to talk is just wonderful because the then Discord doesn't have to guess, oh, I think I'm hearing noise, so I should turn the mic on. It's less than ideal. But if there's a button, then whenever you press that button, it opens the mic and you know when you're going to speak. But on a phone, it is a little less convenient. So yeah, most people just mute their mic, but push to talk, wonderful thing. I love it. Anyway, let me continue. Of course, this is all going to be on a backup on YouTube as well. So let's see what else we have. Now, I feel a little bad, like I'm not doing a good job, because the second question B from quiz 1 is just the arithmetic sequence concept. Now, because it's an open book, you can pretty much just copy this, which isn't how the test question should be. So I'm still thinking of a way to have it be actually something that shows that you understand the arithmetic sequence and not just shows that you can copy stuff from a book. So, but it used to be just what makes a sequence an arithmetic sequence? What does it look like? The fact that I'm adding the same number from one term to the next, and then we have to say what are the two kinds of formulas. So I think a better question for this could be, here is a sequence, specific example. What makes this an arithmetic sequence? What are the two kinds of formulas for this specific sequence? Then at least you have to do a little bit more than, I just don't want a question to just be, here, copy some stuff. Because Fibonacci is already going to be a little bit like that. So we can adjust it a little bit. Here's a specific sequence. What makes it an arithmetic sequence? What are the formulas for that specific sequence? So something like that, yeah. Or a specific example, yeah. What's an arithmetic sequence? Give me an example and formulas for that example. Yeah, it's the same thing. Good. I like it. Now let's have a look at, I think it was E for quiz 1. So that's Fibonacci sequence. Now there's not much to do there. Let's jump past all of this. Fibonacci, I'm not going to deviate from what we have available to us. So the two questions will be maybe use the formula or find a certain number of Fibonacci, a certain number in the sequence. I'm not going to worry too much about these patterns. You still need to perhaps make the Fibonacci squares and draw the spiral. And people's spirals were a little bit less than ideal sometimes. It doesn't have to be super curvy, but it does have to go from the correct corner point of a square to the correct corner point. This diagram is less than ideal. I have to make sure I hit, so where I start over here, hit the corner point to the opposite corner point, to the opposite corner point, to the opposite corner point, and not just cut the square halfway. So that was one issue, and then some Fibonacci numbers in nature. Where's the golden ratio? Now, I'm not going to make a super big deal of this because the golden ratio is a little bit tricky to understand. But everything that I ask will be in some way available from the book. You don't have to search somewhere else for that. On to quiz number 2. Now, I can't trust the voting numbers anymore, so I have to go and remember what was quiz 2. BCE. 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 Venn diagram word problems. Ah, nice. Good choice. Surprising choice, but a good one. So for the Venn diagram questions, I'm trying to find it and speak at the same time. That's never going to go well. This kind of question, exercise 5.2, is the first kind of question I have to be ready for. So here is, we call it an identity, an equation telling me that I can combine sets in 2 different ways and they result in the same set. Verify that this is in fact true by using Venn diagrams. Now we don't have that many, to be honest. We have this one, and then the problems have some, where are they now? I have a couple of other ones. So let's maybe do the first one of the problems. It's not a bad one. Let me just check the chat here. Okay, hold on. Multitasking. BC, what are we doing? Venn diagrams, conditional probability, weighted average. Right. Okay. Can I do a question that is similar to the quiz question? I can, yes. But I'm going to do this one first. Because we don't know which one is going to be on the quiz. On the final exam, rather. So I want to be ready for both. Problem 5.1, number 1. Problem 5.1, number 1. Now, to be fair, we're in quiz 2. To be fair, I did say I will stop whatever I'm doing if someone asks a question, which now happens. So, which number would you like to do from quiz number 2, which is this one, Venn diagram questions? So much nicer if people just talk in the chat room, but I don't know why. No one wants to say anything. I'm just talking to myself. And as a result, I might not do the right one. Yes, last time 5.1 wasn't on the quiz, but it's now available again. It is available again in the review list that I made yesterday. 5.1, correct me if I'm wrong, I believe 5.1 is in that list. It's a Venn diagram question. It has to be in the list. It's a Venn diagram question. So I'm not really seeing exactly. I checked last night. The video is right there. I'm going to link it right now. I checked it. I scrolled around in it. It's there. Now, I can't listen to my voice for more than a few seconds, but I did find it. I will find it for you right now. Because I know it is there. It'll just take a while. Let's go videos. Now, how do I find a live video? I can see it on my end. Let me just check. Huh. It just looks a little different from the way I see it when I log in. Let me see. I know it's there. will find it. So that was the day today. Today's the 14th. Yesterday, yes, like 12 people watched it. I don't know how 12 people watched it then, but I do understand what you're saying. But it does exist. I'm not sure what to tell you. 12 people found it. Well, I'm one of them, to be fair. So 11 people found it. But I do see what you're seeing as well. Let me put it in the playlist and then see if it shows up. Okay, let's see if I put it in my playlist, which I did, in our course playlist. Let's see if it shows up now. Playlists. Playlist. Whoops, that's not it. Go all the way down. Yes, it's number 37 in our playlist now. So I do understand what you're saying, but it's certainly there now. Now I can't see quite as well. Quiz 2, problem 5.1. Yeah, it's right there. I see it. 5.1. Good. Good. Yes. But definitely ask if anything doesn't make sense there or something feels missing. Venn diagram question from the quiz. Let me see if I can open that. I don't want to open yours unless you don't care. Let me try and find it. All right. Yeah, but I need the space. I want to fill it in on the quiz. So let me see. That's not it. Sorry. That's not at all it. Wrong course. This one? Okay, good. Good. I think that's the one. Page 3. Quiz 2 version 1. Okay. Drag this in. Whee. Did that not work? Why not? All right. We are in business. Now, of course, we didn't do this in the test because there was a typo. Is that good enough? Yeah, it's good. There was a typo, so let's just remember the typo or this is not going to go well. So believe we made this 198. And then something else changed. 90 joined room A, 50 room B, 70 room C, 15 joined A and C, 12 joined B and C, and then 4 students joined A and C again. So apparently the correction is 15 joined A and B. I hope those corrections work, but we will see. We ended up scrapping the question, so let's just... Hopefully these corrections are good. Okay, so let's just check the question. All right. So a group of 198, hopefully, students have joined at least one of 3 chat rooms: auto racing, boating, cycling. For simplicity, we'll call them A, B, and C. 90 students joined A, 50 students joined B, 70 students joined C, 15 students joined A and B, 12 joined B and C, 4 joined A and C, 4 joined all 3. All right. Draw a Venn diagram. Let's do that. Like so, universal set. Now they defined it for me, so I'll just skip that step for simplicity. Let's not, I suppose, let A represent the set of students joining room A, and so on. I'll leave that to you. I think my pen's a little big. All right. Now, we have 198 in total. Oh, numbers. Yeah, we want to put in some numbers. What are they even asking? Oh, okay. That comes later. Okay, 198 in total. Fine, we can't put that in right away. So I'm going to work backwards. 4 joining all 3. So that is done. 4 students joined A. Oh, sorry, I need to define these, right? A, B, and C. 4 students joined A and C. A and C. So together here we have 4, but I already have 4. So that's a 0. 12 students joined rooms B and C. 12 students joined rooms B and C. B and C. 12. So that would make that 8. 15 students joined rooms A and B. A and B. 15 here, so that would make that 11. 70 students joined room C. 70. Wow. Okay. I already have 12 accounted for. 70 minus 12. So there is a whopping 58 over there. 50 students joined room B. I already have a good number. I have 15, I have 23. So to get to 50 is 27. 90 students joined room A. I already have 15, so 75 over there. Now, hopefully, if we add these all up, do we get 198, which was the typo? one of two typos. That when you add these up, you don't get 150. You should be getting the total that they give me there. Is that in fact the case? I've done a lot. You should do something. But I will show it in the chat as well, just so you have something to look at. 75 plus 11 plus 27 plus 4 plus 8 plus 58. Okay, well, that's wrong then. That's actually, it doesn't matter, does it? Nope, doesn't matter. It's back. Oops. So we get in the circles here A union B union C, I'll call it. We have 183, yes. So that means there's an outside region that is another 15, which we can also fill in. Now, if you don't fill in absolutely everything here, that's not really what the question is looking at. The question is just asking, do you know what the positions of these circles are? Are you aware of the overlaps? Do you know what a Venn diagram is? The second part is actually asking for a calculation where I may need to put in more numbers depending on what I need. So I want to know how many students joined chat room A, but not B. Let's get some color in here. A, but not B. A, but not B. That is this portion over here. A, but not B. So that's going to be 75 plus 0 in this case. It's not always going to be a 0. 75. Nice. Let's zoom out a little bit. That's too much. That's not. That's too much. I can't find the middle ground here. There we go. All right. And then, of course, in the book that is somewhere, we're done with that. We have a good number of questions that we can practice. There aren't that many because once you've seen how this goes, there's not a lot of variety you can actually do. But there is another one we could certainly use for practice. But the process is always the same. Only put in a number when it represents a single region. Otherwise, put it somewhere else, wait for it, do it later, something. Something. Let me just check the chat here. She is typing a long, long message. Getting nervous. So someone put some questions in the 143 chat, which I'm not going to see necessarily right now. Are office hours being used just to ask questions that we may have? Are we discussing specific problems that we should expect on the exam? All of the above. Yes, I don't check the course chat when we're in a classroom. Okay, I'm just really confused that the problems you had told us to do for every quiz doesn't stay the same for the exam. No, it is pretty much the same. It is pretty much the same. The only ones I've added that I can really think of right now, and I'm sure you'll correct me, is 5.1 and the area volume questions in the very last chapter. I opened that up to get some variety. Variety's good. Variety makes us better. But I think everything else stayed pretty much the same. There's not a lot of variety. Do keep in mind that this is an open book test now. So for the in-person tests, before, it was getting a little overwhelming around the probability chapters, and I wanted to make it better so we don't have to feel like we're memorizing too much because there wasn't a book to look up anything or have any option, any help like that. This is now open book, so it's not going to be as restrictive anymore. But I don't think we've deviated too much from what we have seen before. Those Earth radius diameter questions in the area volume chapter at the end, they're nice. I don't want to exclude them. Don't want to. Now let me just check. 143. Course chat, quiz number 2. What did we say? I can't look at the voting. I need to look at... There it is. Quiz 2, BCE. BCE. Conditional probability, weighted average, mean, median, mode. Okay, good. So unless there's a question, we have 9 minutes. We could do a conditional probability one. Actually, I want to emphasize, not for any specific reason, but I don't think people do the exercises when they should. I want to revisit exercise 2.3, not 2.3, not at all. I'm showing exercise 6.2. That's the one I want to do. Whoopsie. Let's make a new page anyway. People rush to problems and try and memorize them and do I don't know what. Way too much. When the not the pink. No. When the exercises are the ones we need to start with. People skip one like this. This is so nice. So nice. An urn contains 2 red and 3 blue balls, and you make 2 selections of one ball after another. Represent the different outcomes of the experiment with a tree diagram. So I have an urn. I have 2 red and 3 blue. Was that right? There we go. So number 1, let's just see what could happen here. So I have my first selection and then my second selection. First, I'm going to make some straight lines here. We could select a red ball or a blue ball. And I will name them appropriately R1 and blue 1. Then, of course, we need to define these things, let R1 blah blah blah. But in the interest of saving time, that was horrible. I can't have that R visible there. Get out of here, R, and so on. But in the interest of saving time, I'm not going to write out those sentences right now. Then I have a second selection, which could be red or blue again. So I could select the red ball second. I could select the blue ball second. And the same possibilities will be possible depending, regardless of which outcome happened first. All right. So now, did I separate the probabilities? No, I do it all in the tree diagram. So very first, I select 1. The probability of a red ball is 2 out of 5. Probability of a blue ball, 3 out of 5. Now, having taken that first step, and I'm over here, 1 red ball is gone. So over here, what I have is 1 red and 3 blue. So the probability of selecting another red ball is 1 in 4. Blue ball, 3 in 4. When I've taken the blue first path, then the composition changes to 2 red, 2 blue. And my probability of choosing another red is 2 out of 4. Blue is 2 out of 4. There's a lot of typing happening. I'm worried that it's happening in the wrong channel. I don't read all the channels. I'm only reading the main classroom chat channel. So if you have a question that you want me to see right now, we're in a classroom. That is where I am looking. Okay, so that's all of it. Now we can use the tree to answer a whole bunch of questions. Now I'm not going to do all of them because we have 4 minutes left. I'm just going to make up my own, honestly. Let us do them alongside here so we can see everything. I'm just going to make my own questions. Example. What is the probability that I select red? I'm going to do it like this. Red first and blue second. I then go and say, okay, which paths? Well, first of all, is this a normal, I'll call it a normal probability, basic probability, or is it a conditional probability? That is the first decision I have to make. This is just a straightforward basic probability. So then I simply identify the paths, one or more, that gives me this requirement of red first and blue second. Well, in this case, it is only this path. Then the probability of that path I can get by multiplying the numbers along the path. I'll just backtrack to get rid of the pink. So the probability is 2 over 5 times 3 over 4. If I change that to the probability of 1 red ball being selected and 1 blue being selected, is that a conditional probability? No, it is not. Which paths will satisfy the requirement? I can get a red and then a blue, or I can get a blue and then a red. Both of those will result in 1 red and 1 blue. So I can find the probability of each path, and I need to add them together because they are completely independent. So the top one that was pink, probability is 2 over 5 times 3 over 4, plus the bottom one that was pink, 3 over 5 times 2 over 4. Lastly, the probability of, let's say, red second. Let's not say that. Just trying to make up an appropriate question. The hardest one could be, for example, what's the probability that a blue ball was selected first, given a red ball was selected second? Now those were different words. This is now a conditional probability. And when I have a conditional probability, I use my formula to write it to two normal probabilities. So it's going to be the intersection of these two portions. So that's going to be blue first and red second over probability of the given information, which is red second. So then I do them completely separately. The top one has what path? Well, I have to get B1 and then R2. It's the only path that's going to give me that top one. So the probability of that top path is 3 over 5 times 2 over 4. But I have another probability. Let me just reposition my equal signs here. That could create some confusion, I suppose. Hey, there we go. The bottom path just requires R2. So I can get that with the top path or this third path. So the probability of the top path is 2 over 5 times 1 over 4, and the bottom path 3 over 5 times 2 over 4. And I can, of course, calculate those. Now we can do this in more detail with other problems, but we first have to identify what kind of probability it is, and then proceed accordingly. Any immediate questions right now before we end our office hours for today? Just giving a second. No, perfect. All right.
Oh, wait, hello, sorry, I
Oh,
came in a little bit late
there's a
there.
question. Oh, perfect.
Sorry, I was just thinking, I got here a little bit late, but I didn't know if you already answered the question about yesterday's video being up and then being taken down.
No, I honestly don't know why it doesn't show, but I put it in our playlist. So
Okay,
it's at the bottom of our Elementary Education 2 playlist.
okay, gotcha.
Yeah, I'm not sure why it wasn't visible. I did check it last night, but I didn't take it down. I don't know. I'll have a look again, but it is in our playlist now.
Okay, sounds great, thank you.
All right. All right, then until tomorrow, I pop in and out of Discord. If you have any questions, I might spot them, so feel free to have a chat. Otherwise, I will see you guys tomorrow. Thank you.